Hello and welcome back to my channel. Today on the bench we have this beautiful IBM PS2 Model 30, it's the 8086 version, which I tested on one of my previous videos. You'll find the link down below in the description. When I tested it, it worked, but it had memory errors, floppy errors and hard drive errors. So I guess it's about time that we take a look at it and see if we can fix it. Let's take a look. Right, before I start looking into floppy and hard drive or anything else, I really would like to make sure the base system is working. So this system has a memory error showing up on screen, and IBM Museum on my channel mentioned that this computer has 128 kilobyte on the motherboard. And then I consider a couple of memory modules here on that you can see through the side of the computer, which should be 255 kilobytes each for a total of 640. So I should be able to get at least 128 kilobytes working if I remove those modules. But let's take a look. The motherboard is in okay shape. I hope, finger crossed, it just needs a little bit of cleaning, some contact cleaner, and those memory modules will be okay. So the next step would be to disassemble this whole thing, remove all the boards, remove the riser, remove the floppy, the hard drive. I'm probably going to have the board outside of the case, clean it there, inspect it there, and test it there. So give me a minute and I'll take everything out. Right, here's the motherboard completely out. As you can see, it could be in better shape. I guess it could be in worse shape. Now, before I start touching anything on this motherboard, I think I'd like to power it up as it is, and just confirm that I still have the same memory error before I start touching things and resetting chips and everything. Let's grab the power supply, VGA cable, and power it up and see if it still does the same thing. Right, everything is connected. Got the power supply, the VGA cable. In 3, 2, 1, go. Okay, power supply is on, no smoke, which is good. And yeah, well, that is good. We have exactly the same memory error, and obviously date and time, there's no battery, and diskette, there's no diskette connector. So perfect, that's all I wanted to know. We know we have the same error message, and we can have a look at this memory error. So this is where the extra RAM is located on the board. Unfortunately, I'm noticing that one of the clips holding the stick is broken already. I didn't touch this, so it came like that. These clips are notoriously for breaking, and one is already broken, which is not great. Now, I don't see corrosion or anything in there. These two chips in here are not in the greatest shape. I can see, well, a little bit of corrosion and age on the legs, so yeah, I guess it would be nice to take them out. The whole board, as you can see, is mildly corroded, or oxidated maybe, and full of dust. So I guess the first thing I'd like to do is to give the board a wipe, and then I might want to try and remove these memory sticks, hopefully, finger crossed, without breaking the clips. What I'm going to do, I'm going to use Epictronics method, and I'll put a little bit of lubricant where the clips are basically clipping on the memory. Hopefully that will help a little bit. Anyways, let's give a clean to this thing, and also I'll remove these corroded chips, put a little bit of contact cleaner, inspect the legs, including maybe the CPU up here, just remove it and clean everything and see if that sorts out the memory error. That would be great. Right, if I'm looking at the sticks, well, there's nothing horrible, like on the Macintosh thing. They're from Texas Instruments. And yeah, I don't see anything massively wrong. Maybe there's a little bit of corrosion here on this one. They definitely need a good clean. These look like gold-plated pads, so hopefully there's nothing massively wrong with that. So let me clean the board, and then we'll move to the ICs. Okay, I gave the clean a little... Okay, I gave the board a little clean. It needs a wash, to be honest, to look nice and maybe to stop the oxidation or corrosion, whatever it is, from progressing. I've noticed something at the back. Now the back, as you can see, is in very good shape. I don't see corrosion or anything. That being said, I've noticed this and I'm not sure what it is. It looks like someone has painted some solder mask on the board. Maybe there was an imperfection and it was corrected by hand. After all, these were expensive machines back in the 80s. Well, definitely not something I can rub away with alcohol, and even under the microscope, all traces look fine, so probably nothing to be concerned about. If anybody knows more about this, please do leave a comment down below. Right, let's go back to our memory problem. I'm going to use some of my contact cleaner. This is the one I'm using. I've been told by some of my viewers that you can actually buy the Oxid in the UK. It's on Amazon. I don't know, maybe next time I'll buy it. For now, I really like this one. Every time something doesn't work with the normal contact cleaner, this usually fixes it. So let me wipe some contact cleaner on the memory modules themselves. Right, next I'll spray some cleaner directly into the sockets. But the sockets look like in good shape, so that's good. That's good to see. I'm adding a little bit of lubricant, grease actually in this case, where these clips are, to try and reduce the friction. Okay, I got the power supply connected back. Let's power it up and see if the memory issue has gone. In 3, 2, 1, go. And no, we still have the memory error, so... Well, I would say let me try and boot up and hold that memory module in place in case it changes anything. So I'm pushing on the module, let's power up. 3, 2, 1, go. No, it only says 128. Okay. I'm not familiar with the PS2, but I think the next step would be, what if I remove these modules? Do I still have the error message? Because one scenario is also that one of these modules is faulty. Aha, so we don't have the memory error anymore. So the next step in diagnosing this, to be honest, would be to try different memory modules. Now, it's not easy to find PS2 information online. I mean, there is a very nice website, which I'm gonna link here and down in the description. But if you Google it, there's not much, to be honest. And what I could find online was that IBM used non-standard 30-pin memory modules. I think there were some parity check pins swapped around. So you couldn't really just use standard SIM modules. And obviously, if you try and buy modules designed for IBM, they cost an arm and a leg. But most importantly, they come from abroad. They are already very expensive. Plus, you have to add quite a lot of money in shipping, and not really. And the other thing is, these might be working totally fine, and the problem is on the motherboard. So one option would be to get a standard SIM module and mod it. Now, I could do that, it's no big deal, but still, the fact that I don't know whether my mod is working is not gonna help with the troubleshooting. Because what if the computer still doesn't work? Is it my mod? Are these modules working, not working? Can I buy new ones? They come from the US, it takes a month, and then they're still not working. Are these modules defective? I don't have another PS2 to try. But long story short, it turned out that IBM apparently, at least according to the schematics I have, started using those non-standard modules on the 286 version of the Model 30. Mine is an 8086, so I can use standard modules. Now, the board only supports 256 kilobytes modules, let's call it expansion, to go to up to 640 kilobytes. But then I thought, wait a minute, if these, which are coming from the IBM, are standard SIM modules, then I should be able to test them. And that's the reason why I have one of my older boards here. This is a 386SX computer. Now, this is an 8-bit machine, because the SX, if I'm not mistaken, is basically a 286 with 386 extensions on it. This is an AMD 386SX at 40 megahertz. So what I've done, I have plugged two of my modules. I believe these are 2 megabytes each. The reason I got the SX out is if I get the DX out, or a 486, I would need 4 of this. I don't have 4 of this. I want to test these 2. And I should be able to test these two on this machine, because being an 8-bit machine, it only needs 2 modules to cover the full address of the addresses of the CPU. So I haven't turned on this machine for a long while, so first I'm gonna test it with 2 of my modules, make sure it works. Then if it does work, I'll try the IBM modules and see if they do work. If they do work, I know I have an issue with the motherboard. If they don't work, I'll order 2 new ones. In 3, 2, 1, go. It is booting up. Actually, are these 256 kilobytes each? And actually, yes, these are 256 kilobyte RAM sticks. I think I bought them to try and fix a video card. Anyways, happy days. These are working, and probably I can use these on the IBM themselves. But since we are here, let's try and test these 2, which are coming from the IBM, and see if by any chance they work. Okay, the IBM sticks are in. Let's power up. See what happens. 3, 2, 1, go. Stuck on 1312. I don't have a picture. Might have some beeping. Well, it doesn't beep, but it doesn't boot up, which is great. So I would say I don't need to buy them. I have them. Assuming these are compatible with the IBM, let's give them a go. Right, back to the IBM. I've got, as you can see from the different color, the 2 new 256 kilobytes RAM modules. Let's power up and see if it works. 3, 2, 1, go. Look at that, it's counting the memory. Yeah, that's what I was looking for. Cool. Just 2 faulty memory modules. Amazing, right. That's great. Memory error has gone. There you go, fix that. Now, I'm not a big fan of the if it works, don't fix it, if I'm saying that right. But I still would like to remove, these are the BIOS chips and also the CPU, basically the only socketed chips, just to make sure they're in good shape, put some contact cleaner in it, make sure that I don't have any intermittent issues later on. Since I have the board out, I think it makes sense. Okay, well, this is good news. The corrosion, it's only external. There's no corrosion, at least I don't see any, where the contact actually happens. A little bit of contact cleaner is definitely going to help, but this is great news. And this is also in good shape. That's good. That's absolutely good news. And this is the CPU, the 8086. I see there's a little note. 120? Not sure what that means. If anybody knows what that means, please leave a comment. I'll be curious to know. And this is in great shape as well. So yeah, it's great that this computer seems to be a bit crusty on the outside, but the main components and the sockets and all the components seem to be in good shape, which is great. Okay, just a quick test to make sure that everything works as it should. 3, 2, 1, go. And yes, it does. Perfect. So we can move to the next step. Now, the next step before we move to the floppy disk would be for me to make sure that the system works reliably. Because the last thing I want to do is to start playing with the floppy and then things don't work and it's like, right, is it the floppy not working reliable, or maybe there's an issue with the RAM again? Because again, it's posting. But I really would like to boot into some software and let it run for like memory checks and make sure the system is reliable, and then move to the floppies. Now, as you might know from my previous videos, these floppy disk doesn't seem to be working. I'll try to fix it today, well, on this video, but I would say not yet. So I've been looking into this, and it turns out that these PS2 floppy drive basically uses the same communication protocol than a standard floppy drive, but the pinout is completely different, and also obviously this is getting power as well, so it's different, but it's more or less compatible. All I needed to do was to mechanically adapt the PS2 interface to the one used by a modern floppy drive. I found this project online. It's from user Greg Daville, who forked it from user TubeTime. And it's a simple PCB which routes all the lines from the PS2 so that a modern floppy drive can be used. I cannot design my own PCBs yet, so these open source projects are amazing. All I need to do is what is called a Gerber file. It's a zipped package which contains all the necessary information for the manufacturing of the PCB. For this project, I used PCBWay. They have kindly provided the service for free, and they're also sponsoring this video. I really know very little about PCB manufacturing, but thankfully the process is very simple. I downloaded the Gerber file from GitHub, and you might struggle a bit to find the correct files. That depends on how well the project is organized. Then I uploaded it into the PCB Instant Quote section on PCBWay.com. That's it. The website will load all the correct parameters, and most of the time you don't have to do anything. Well, you can change the solder mask color if you want. At that point, it's just a matter of choosing a shipping service, complete the order, and wait for a delivery. The resulting PCB is pretty nice. It looks very well manufactured and finished. Now I can solder on the 34-pin socket, a power lead, and a few 1 kΩ SMD resistors as shown on the drawings. Somehow the design did not include the key to match the socket, and as I said, I'm not good at using KiCad yet. So I just used my Dremel, and the result was pretty good. Thank you PCBWay for helping out on this project. Here's the final result. It looks lovely and I think it's ready to go. Right, back to the PS2. My MS-DOS floppy is ready to go. So let's power up and see if by any chance I can, for the first time, boot this computer into MS-DOS. Okay, 3, 2, 1, go. Counting memory. I do remember when I was a kid and we were switching on these computers and it was taking its time. Obviously complaining about dates and time because there's no battery. Finger crossed. Will it work? Yay! It's working! Look at that! Yay! It's booting into MS-DOS after who knows how many decades, I guess. Fantastic! Look at that! Okay. Well, we don't care about the date. 6.22, that's great. Now it's going to be the interesting task of running my checkit from another floppy when the operating system is on a different floppy. But let's try, okay? Let's see what happens. Okay, perfect. Oh, it's just so slow. Check it. See if it runs straight away or if he asks me to go back to the OS. No. No, it's working. And we got color. This is probably my slowest machine. Previously it was a 286. Here we go, we are in the main menu, so let's start the memory test. And I can start a quick test. It's listing 640 kilobytes. I can start this way. Oh, it is very slow. It doesn't show any sign of life. Oh, there we go. It's definitely working. I got a couple of question marks now showing that it's testing the beginning of the memory. Right, I guess I'll let it run for a while, several cycles. And yeah, it's now completed the first 2 blocks, whatever that means. It's only 640 kilobytes, it's taking forever. Okay, good news. The system passed 2 cycles of long memory tests, no errors. It's taken about 45 minutes for 640 kilobytes. And I've managed, not without difficulties, to create a copy of the official IBM diskettes, the starter diskette and the diagnostic diskettes. Now, I thought the diagnostic diskette maybe had something a bit more customized for this board, since it comes from IBM, but it's nothing special, to be honest. I'll show you in a minute, but I don't think I can do anything that I haven't done already with Checkit. Let me show you. The diagnostic diskette welcomes you with this menu. The section I'm interested in is the system checkout one. Once the list of components is confirmed, I am presented with this list of tests. If I run the system board test, unfortunately I get a date and time error. That is because the battery is missing, but I believe I can set date and time and the system would retain it even if powered off for a few minutes. But I did not know that when I recorded this, so the test just failed. The memory section seems interesting, but it only takes a minute to run, so I guess the 45 minutes test done in Checkit is slightly more accurate. The test ends with code 200, which I hope means all good. So it looks like, despite being written by IBM for this specific machine, this diagnostic package is really nothing special. Well, to be honest, I would say let's move to the next step. The motherboard totally works. It's been on for a few hours. It passed all the memory tests, all the logic tests that I could find, and obviously I could load software. It's working. It's been very reliable. It hasn't glitched a single time. So I would say now it's time to replace the depleted battery on this Razer board. It's a 3 volts non-rechargeable battery, so a CR2032 should be perfectly fine and will not require any modifications in order to prevent the system from charging it. Now, there are many ways I could accomplish this. I have some CR2033 holders in stock, but they're never a plug-and-play solution, as the legs of the holder are only 21mm apart and I need 34mm here. Obviously, I could just run some bodge wires, and I know it could look okay with some modifications. But I was hoping for something more elegant, and I know this is very subjective. Now, if you watched my Macintosh SE video, I ended up making a small interposer for the holder, as I didn't like to just throw the holder at the motherboard and attach it there somehow. The good news is that one of my viewers, kpanic23, recommended me the SMD version of the CR2032 holder. Here it is one. Somehow, the distance between the pads of the SMD version is much more than the distance between the legs of the through-hole version. Now, this is still not enough to end up exactly on top of the existing pads of this board, but I feel it would be much easier than the standard holder to adapt. So let me see if I can come up with a solid and elegant solution here. Right, this is my idea and I think I really like it. So I run a metal wire, it's a leg of a resistor, between these two pins, but I made this little curve. I also have this L-shaped pin coming out of the hole like that. Because the idea is, yes, I could use some super glue and just stick this to the PCB, but I know it's never going to happen. My concern is one day this breaks and I need to remove it. It will probably destroy the PCB or potentially damage the PCB. So that's my positive, that's my negative. So I think it's going to work like this. So that fits under the wire and that fits under the wire. So once this is soldered, it's going to be like this. It's going to fit totally fine inside this rectangle. And I think it looks amazing. Let me solder this in place and see the outcome. Right, here is the outcome. Obviously, the way this is soldered, this is totally stable. It doesn't need any glue whatsoever. And I really like it. Look. This is the, when I said something elegant, that's what I mean. Now I know I'm boasting my creation, but it really looks nice. It's flat and flush with the PCB. There's no glue, there's no drills, there's no. Yes, you can see those little wires, but they look okay. Nothing at the back, and this should just work. Thank you so much, kpanic23. I mean, this is absolutely fantastic. I've been looking for a solution like this for a long while. Well, enough with tests. What I'd like to do now is to plug this back in, set the time and date, and then run some software and just use this computer. Right, so time and date is set up, so let's restart into MS-DOS, make sure that the time and date is there. Well, it's definitely there, because there's no error message anymore. Fantastic. Yeah, time and date is there. Actually, would you believe that this thing is year 2000 compliant, apparently, because it's reading 2023. I mean, it is just mind-blowing. It's mind-blowing. To end this video, I selected, I would say, a classic for this machine. Well, it works. I'm pretty happy with the results so far. The system has been pretty reliable. The motherboard just works with the modern floppy, of course. The power supply works. I mean, if you think that this thing is, 40 years old? It's 30 something. It's just absolutely amazing. And this game It's never been my favorite, but it looks amazing and it just works flawlessly. On the next episode, we will take a look at the floppy drive, maybe the hard drive, but I can tell you straight away that the floppy disk is not gonna be an easy fix. So this is it for today. I really hope you enjoyed this video. If you did, I would really appreciate if you could hit the like button down below and also consider subscribing to my channel if you like what I'm doing here. For now, thanks for watching. As usual, I wish you a great day and I hope to see you soon again here on my channel for my next videos. Thank you very much and goodbye. Bye.